Boo! Welcome to our special Halloween edition of Azure plus Chef equals awesome. Don't get spooked by Lamp on Azure. I'm Shannon Smith from 10th Magnitude, and I'll be your MC for the next hour. I'm going to be joined by Matt Stratton and Jeff Rack, and they're going to demonstrate why Linux is a first-class workload on Azure. A few housekeeping items before we get started here today. We're going to be doing our question and answer session at the end, but if you have questions throughout, feel free to enter them into the chat pane on your panel. We'll keep track of those for you and try to answer as many of your questions as possible. If anyone's having any technical difficulties, please let us know through the chat pane as well, and we'll try to go ahead and address those for you. Finally, this webinar is going to be recorded, and we'll be sending out a link once we've got it up online. All right, you should see our agenda for the next hour on the screen here. We'll do some introductions, and then Jeff and Matt are going to cover provisioning Ubuntu and Linux VMs from the command-line interface. And they're going to configure Apache and MySQL via Chef, manage Linux nodes via the command-line interface and web portal, demonstrate self-healing infrastructure, and then we'll do our question and answer session. So let me introduce you to Jeff and Matt. Jeff is a senior consultant at 10th Magnitude. 10th Magnitude is a 360-degree cloud services firm that provides Microsoft Azure migration, DevOps-enabled automation, and web, media, and mobile application development. They specialize in the Azure cloud platform and have worked with it since its launch. Jeff brings over 20 years of experience in the IT industry, and he's a big fan of dry humor and pastrami sandwiches. Matt Stratton is a solutions architect at Chef, where he demonstrates how Chef's automation platform provides speed and flexibility to clients' infrastructure. He's devoted to concepts like continuous delivery and continuous integration, and his license plate actually says DevOps. All right, that's it from me. I'm going to hand it over to Jeff so we can go ahead and get started. Oh, and actually, let me just, I noticed here we have the link actually to our first episode on this slide here. So if you're watching this recording and you realize, hey, you want to catch up and review a little bit introduction to Azure and Chef, the link to the recording is right there. So now I'm going to hand it over to Jeff so we can go ahead and get started.
Thank you, Shannon. I'm going to start this off and discuss what is Azure. And for those of you that have tuned in and seen some of our other webinars, you're probably pretty familiar with this, and this will be a bit of a review. What is Azure? Azure, in short, is Microsoft's cloud platform. It is a collection of integrated services that include compute, support, storage, data, networking, and application offerings. They include IaaS and PaaS, and today we're talking about IaaS, primarily Linux, which, as Shannon said, is certainly not a second-class citizen or second-class workload in Azure. We see the list here on the screen of operating system options that are pre-built gallery images. We see all the different Linux images that are available as pre-built images. And I certainly want to call out one new addition as CoreOS that is currently in developer preview. We're pretty excited about that new Docker edition. Additionally, we also have the bring your own image operating system version, which you can really create any image that you want and upload it into Azure. So you will always have that option to consider. We also want to point out here Azure is going to be manageable from any OS. It is API driven, which certainly means you can hit it from the APIs can be hit from a browser on any operating system. It is in a web portal. We could also talk about the fact that you can use the command-line interface from the Linux platform with the Node.js tools. or if you want to still use a Windows platform, the PowerShell tools are available in the command line. So we have a lot of options on how we're going to have at these systems. There's also the Azure Marketplace, which is a totally different set of images that we can use that are pre-built images that are all set up and ready to be deployed. And there are a lot of Linux systems in the Azure Marketplace. I just wanted to call out a few just to point out because a lot of people are not aware of some of these systems. As you can see, Oracle Database, Nginx, ClearDB, that's hosted MySQL, LampStack. I mean, there's I don't know, at least a dozen, probably a couple dozen different LAMP stacks that are set up and ready to go. Checkpoint Virtual Appliance, and there are several different Checkpoint Virtual Appliances available in the marketplace. And all of these systems are just ready to deploy push-button managed systems that you can just get going and be out of the box with in a matter of minutes. They are all some really, really cool stuff.
So where does Chef come into this equation? This is Matt Stratton now. So like Jeff mentioned, he said there's some pre-built workloads you can use in Azure, but really if you're looking at being able to configure your systems for your particular special Snowflake needs, that's where Chef can really come into play. So Chef is an automation framework. And you want to think about Chef as allowing you to implement your infrastructure as code. And what infrastructure as code means is that our infrastructure is versioned, it's tested, and we're using the same rigor and process that we're used to doing with application development. We can apply that to our infrastructure. What's great about that is it means we can trust these changes that we're making, and we can understand the state that our infrastructure is in at any given time. With Chef, what we're doing is describing what we want a system to look like, and then Chef will ensure that system remains in that state. An important piece is that the Chef server is completely API driven. So if we want to use our command line utility, which we call Knife, to communicate with the Chef server, that's great. If you want to use the web interface, that's great. You could also integrate it with any other existing systems you have that are able to consume a REST API. So potentially you may have some part of a deployment system where you say, now I need to be able to roll out the change via Chef. You're able to facilitate those changes through the API. Chef's domain-specific language, the language you use for describing your infrastructure, is based on Ruby, which allows you to extend it as much as you need to, but you don't need to be a Rubyist to do Chef. I am a grand example of that. I am the world's worst Rubyist, but I can write some pretty good Chef code. And this extensibility allows you to use Chef to meet whatever your current needs are, but also know that it will give you the flexibility down the road. You don't have to have your crystal ball to know all the things you're going to need to do over the next 5 years. And similar to Azure, in some, Chef is multi-platform, so Chef supports variants of Linux, other Unixes, AIX, and Windows, all as first-class citizens. So you can use Chef as your one tool to manage all of those systems across the board. A couple high points about Chef to keep in mind is the idea of multi-tenancy. So this allows you to have one Chef infrastructure for your entire organization to allow different lines of business or divisions, if that's applicable, in order to combine simplify the complexity of that. We provide high availability with automated failover and load balancing, as this is a critical part of an infrastructure. We also have the idea of role-based access control, so you can have granular control of user privileges as to who has read access to configuration, who can actually change configuration, which can really help meet compliance and security concerns around this type of work. Our enhanced management portal, we've got reporting, we've got audit logs, so you can generate all the reports and graphs that will make everybody happy in order to see the entire organization all the way down to individual servers. And if you're already using some type of LDAP, including Active Directory, for your authentication, Chef can leverage that, so you don't have to sit there and say, well, I've got my Chef account and then I've got my AD account. You can use that from one level of authentication. And then as our enterprise customer, we have enhanced enterprise support. We've got the offerings include premium 24/7 support to working with our customer success engineering group to basically help you be successful with Chef. there's unparalleled flexibility. If you're a licensed user of Chef, you can either put a Chef server on-premise behind your own firewall, you can use our software as a service offering, or any mix and match of that is appropriate. I want to create a new virtual machine in Azure. I want to configure it with Chef. And one of the ways that we can do that is through the Azure Management Portal, which is what we're going to show you. I've got kind of a business idea here, Jeff. Jeff and I are, this might be our temporary gigs before we make our internet billions with our new social network, which we are calling MyFace.
This is it. It's going to be big, Matt.
So in the case of this, now we know that we're going to be starting out small, but we have big dreams. So using Chef and Azure, it's going to let us be able to quickly add more servers as we need to and trust their configuration to match without having to have an army of sysadmins making with the typey every time we've got a million more MyFace users. So, but to start, we want to create our very first MyFace server, and we're going to do this using the Azure Management Portal. All the files necessary to do this, we only need 2 of them, and they can either be stored on my workstation as the person doing the provisioning, or I can actually store them in Azure storage. So that way, anywhere that I have access to a browser and my credentials, I can go ahead and spin up as many MyFace servers as I need. All that you need is a file called the client RB, the validator key, and the optional run list. So, Matt, you say, what are those things?
What are those things, Matt?
Thank you. First of all, so the client RB is the configuration for what we call the Chef client, for the machine that's being configured. Not all the configuration of what it's going to do, but just how it knows what Chef server to talk to. So you can see at the bottom of this slide, there's the 4 lines that I need for my client RB. The important part is line 3. It has the Chef URL that just says that's the endpoint that this client is going to talk to, and then the name of its validation client. Why this is important, this is the authentication that says this machine is allowed to talk to my Chef server and get configuration from it. Just knowing my Chef server, you shouldn't be able to go and build as many MyFace servers as you want because, hey, I can't have you stealing my billions. So the combination of the validator key, which is a private key, and then the URL, the public key for the validator is stored on the Chef server. So when my server that I want to configure goes out to the Chef server to say, hey, I'm ready to be configured, I'm ready to do my thing, the use of the public and private key encryption and authentication and authorization ensures that only servers I want are able to do that. So that's all fine and dandy for me to talk about it, but it's far, far more interesting to actually see it. So let's go ahead and demonstrate configuring a virtual machine in the Azure portal. So I'm here in the Azure Management Portal, and I've got a couple virtual machines running, but we'll look at those later. But for now, I'm going to create a new virtual machine. So in this case, I am going to create a new machine. I'm going to look, and we're going to make this an Ubuntu 12.04 server. So I select the image that I want. I'm going to give it a name. We're going to call it Matt MyFace 1 because I'm clever like that. And because I'm expecting a lot of traffic, I'll go ahead and bump it up to an A2, 2 whole cores and 3.5 gig of RAM. And instead of using the username Azure user, I get to create the username I want to use. If I wanted to, I could upload an SSH key if I wanted to do key-based auth. In the interests of expediency for the demo, we will just do password authentication. So I type in I know watching me type in passwords is about as exciting as it can get, so consider yourselves lucky. But of course, checks to make sure that my password is not terrible and that at least it matches. And now I'm going to sit here and we'll put this inside of a network I've already built. We'll store it in the storage account that I already have in place. Now it's important here I enable that I want it listening on port 80. And actually I'm not establishing that it's listening on port 80. I'm allowing port 80. Because if I blocked web traffic to my amazing social network, it would not be very social nor network.
No.
So we'll go ahead and do that. And now the fun Chef part. So I get here and I can say I want to configure this with Chef. So number one, I need to pick my client RB, which I could have chosen from my workstation, but in this case, I already have this out here in Azure Storage in the cloud. And this is a storage account that only my account has access to.
Exactly.
It's not just anybody on the internet can get at it, only people in my organization. So I choose this client RB that I want to use. I'm going to do the same thing for the validator PEM. And then I'm going to specify the run list. Now the run list is the list of things that I want this server to be configured for. So in this case, we've created a role, and a role is simply a list of different recipes. It might be run the MySQL recipe to configure MySQL. It might be configure the base security, all these things. We've created a role called MyFace server, MyFace-server. And then this will tell Chef, oh, MyFace server, not MyFaces. That's the role to apply. And now what's going to happen is we can see that it is actually starting up my virtual machine down here. And it's going through its provisioning state. This is going to take a little while. So this is why we have a couple of VMs already running. We can do our TV Chef thing in a little bit. We'll show you the results. But while this is what's happening here is it's starting the VM, and it's going to install the Chef client software and then reach out to the Chef server to get its configuration. If I'm going to be wanting to spin up thousands of VMs, I can't be making with the clicky. So Jeff is going to show us how to do this with some command line ninja skills.
Exactly, Matt. I think there's another way that we can do this. As much as I love doing this in the console, and I think it's really awesome, we're going to have to hit the command line here and see a little more growth. Let's talk about how we can provision this guy from the CLI. Let's talk about using Knife Azure. Knife Azure is an extension that is an extension of the Chef command line tool, Knife. And Knife Azure will allow us a lot of different options, pretty much most options that are available in Azure. It'll allow us to set VM size, storage account. We'll choose the source image. We'll choose whether or not we want to put it in availability set, cloud service. As Matt showed us, we will be able to provision endpoints, that port 80 endpoint that he set up. We can really have a lot of options using Knife Azure. And what will happen is Knife Azure will then communicate over SSH to actually bootstrap or provision the machine. What does Chuck Norris do, right? Chuck Norris intimidates the VMs. Let's do the same thing. What I'm going to do is let's take a peek at some configuration here before we actually execute anything. So we got a couple things to look at. Let's show you the Knife RB first. This Knife RB is actually somewhat similar to the client RB that we saw a minute ago when Matt was working in the portal. It's fine. We'll see we have some of the same things in the client name, the validation key, Chef server URL, but we have some new items that we didn't see before, and these are some Azure-specific settings. We have the location of our local published settings file, which is what allows us to create our connection to Azure. We have the Bootstrap version, which is actually the version of the Chef client that we're using. We're using version 11. And here we have the source image, which is image name of the Ubuntu 12.04 client. It's the actual full name of the image that we pulled down. And this particular setting here is the TCP endpoint, saying that we wanted to create that endpoint at port 80.
So it looks like, Jeff, you're setting configuration settings that were similar to what I was doing by clicking around in the web interface.
You got it. You got it. We're doing the exact same thing, but we're going to be doing this on the command line. And in this case, I'm actually doing it by writing a small shell script. And here's this guy here. This is the actual script that I have set up.
Jeff is now proving that he can be replaced by a very small shell script.
Yes, exactly. That is my goal in life. Always has been. Here is the Knife Azure Server Create. There's the actual DNS name of the actual server name, VM name, Chef Azure Awesome 01. The size of the machine, it's medium. The We're putting it in the West region. I chose not to share the username and password because I didn't think you guys would all enjoy having that information.
They might enjoy it. We wouldn't, because they're going to come steal our billions.
People don't want to be tempted. They really don't. They don't want to be tempted with our billions, Matt.
That's true.
But yeah, this is pretty. And actually, most of the options that we have here in the knife RB could also end up on the command line. I chose to put them in the knife RB just for the instead of typing them on the command line, put them in the knife RB for a simpler reason.
And then vice versa, I assume I could use those command line flags. I could pre-bake them into the knife RB. So if I had some type of automated provisioning that I knew I wanted to spin up thousands of, and I knew they were always going to be mediums, for example, I could put that into the base configuration file.
I am nodding vehemently and thumbs upping Matt, but we don't have video. And here we go. And we're off. We are now setting up MyFace server on Azure. Very exciting stuff. And this will take a good 10 minutes or so. But through the magic of television chefs, why don't we show you our pre-baked Chef Azure system here. This is Chef Azure Pre-Bake 2, and this is actually a LAMP stack system that is a PHP application which utilizes a MySQL database and runs with Apache. And I know we got you guys excited. I mean, come on, you're feeling it, right? The MyFace app is the next big thing. So feel free to jump in and take a peek at it. The pre-bake is Chef Azure Bake 2, cloudapp.net.
Also, so now we have this pre-baked VM. So we saw that it's chugging away here, Chef Azure Bake. Here it is in Azure, chugging away. Jeff has shown us the result of it being fully functional. But then if we go take a look inside of Chef, and we take a look at Chef Azure Bake 2, we can see how this has actually worked. So we can see a couple interesting things about this machine that it knows. So it knows that remember we said it has a role called MyFace Server, so we can see that's in there. And then if we take a look, and we can say if we look at its run history, and we take a look at this machine, so Chef Azure Bake 2, we can see that it only took, the last time it ran, it only took a few seconds, and it was successful. So we can see this, and the thing is we should see Chef runs that are very short, because fundamentally, what Chef is doing every time the client runs, it's not saying do these things, it's saying are these things the way I expect them to be? And in the case of this one, you can see there are resources executed and then the total. 2 of 101 resources were changed. So there were 101 things that Chef was checking on, and 2 of them it had to change. In this particular case, it just has to do a little bit with how the MySQL user parameter works, why it will always think it has to change that. But it's not really, but versus you'll see when we get the first one to come up, you're going to see it has to change a lot of resources. Yep. Because a standard, fresh out of the box Ubuntu 12.04 machine from Azure certainly is not in the state of a MyFace server. A MyFace server is not in the gallery yet.
Yeah, not yet.
So we'll take a quick review of the components of Chef when I'm creating this configuration, and then we'll take a real quick guided tour through the code for the MyFace configuration. So in Chef, the lowest level of configuration is a thing we call resource. That's an item of configuration. It's a thing you want to ensure is in a certain state. So an example of a resource might be a package. It might be a directory. It might be a user. And I'm specifying the definition I want for that. I want Apache to be installed. I want the user, Jeff Rack, to not exist on this server. That would be kind of mean, but I could do that if I wanted to. I could ensure that a certain directory has certain permissions. And what happens is Chef just says, that's a thing, I want it to look like this. I will make sure it looks like this. Now those resources get rolled up into something called a recipe. And the recipe is simply a list of the resources that we care about and the order in which we care about them. Now this doesn't mean that it's a list of steps to take. It simply means that some things might be dependent on one another. For example, it doesn't do me any good to check to see if Apache is running before I've confirmed that Apache is actually installed. So therefore, that's where the order matters. And then finally, we roll recipes up into what are called cookbooks. Cookbooks are a set of recipes plus supporting files if there are templates, if there are additional pieces and parts that those recipes need to do their job. And you can think about a cookbook as a defined set of items and outcomes for a system. So an example of a cookbook might be a cookbook called Apache that's used for installing and configuring Apache. I also might have a cookbook called MyFace App, which is the cookbook that's all the things to do to configure the state is a MyFace app. And cookbooks can depend upon each other and they can interact with each other, just like libraries might be somewhere else, so you don't need to go and recreate the wheel for every single thing that you're going to do. Now, that being said, let's take a quick look at what the code for the some of the things we're doing when we're executing the MyFace recipes. This is the recipe for the role of web server under the MyFace cookbook. So this is the recipe to configure a web server. We have a multi-tier application. It's got, because again, we're talking about a LAMP stack here. We've got Linux, we've got Apache, MySQL, and PHP. So this is where the PHP piece might come in as well as the Apache piece. So we're going to see a couple things that it's going to do. One thing, our application requires there to be a group on the machine called that's used for MyFace. And in this case, by doing this is setting it as what's called an attribute. So instead of hard coding it into my code, I'm separating configuration from code. So I'm able to specify that where it says MyFace group, I mean it should be called MyFace. This could be something different. I can set these attributes for lots of different reasons. So I might have a different group name if it's in production versus QA, etc. So this is ensuring that that group exists. If the group does exist, Chef won't do anything. If the group isn't there, Chef will create it. Similarly, we have a user resource that will create the user for MyFace. And it's going to do a couple things. It's going to, A, make sure the user's there, and if not, we'll create it. It's going to make sure it's in the MyFace group, and it's also setting it as a system user, as a service account, so it doesn't allow an interactive login. Then down here, we're going to do a couple things. By using the existing Apache 2 cookbook, we're going to disable the default website because we don't want that running. And then we're going to modify an Apache config file with our particular parameters. So it gives us a lot of flexibility in how we want to actually address these particular changes, be they on configuration files or others. So now we talked about the run list. So the run list is the list of recipes a node will use. We said, for example, in the case of the role MyFace server, it had a list of recipes that it did. Now, we can modify this run list in a couple different ways. We can do it via knife. So this command, this particular knife command, which is knife node run list add, will let us append a recipe to the end of the run list. We can also do it, and you can see in that screenshot down there at the bottom, that shows you the outcome of that. That was adding the Chef client cookbook recipe, default recipe to that particular node. That's doing it at the command line. We can also do it through the portal. So we're looking at here, we have our different nodes that we've created that are in our Chef server. And for example, we're going to take a look at Chef Azure Baked 1. And if we take a look at its run list, we can see that the only thing in its run list is the pieces for MyFace. What I want to do is I want to add a cookbook. I want to add a recipe that will configure the Chef client. By default, the Chef client will only run on demand, but it can be configured to run daemonized as well, so it runs on a schedule, which is usually a good practice. Now, there's several different ways we can do that. One of the easiest ways is to use Chef to configure Chef. So one of the things that the Chef client cookbook does is it configures that particular on the machine that it's running on. It configures the Chef client to run every 30 minutes with a 5-minute randomization at the top at either end of that, so you don't have all of your billions of MyFace nodes all checking at the same time. Not because Chef can't handle that, it can, but because you might not want every single one of your servers changing their configuration at the same time. So to modify the run list, I simply click on, I say edit for the run list, and then I know that it's called Chef-client. I simply drag it over here. I save the run list, and now it's been added to there. But let's see what it actually does. So now that we've added it to that role, we're going to need to SSH into the machine so that we can actually run the Chef client to get its new configuration. So we'll take a look at what it's going to do when the Chef client runs. So it's going to execute its run list as we expect, including, so you can, well, it went by pretty fast, but it's downloading the cookbooks that are necessary for the configuration it wants. And you can see it updated 2 of 70 resources. So we can see that it has completed its run, and now Chef is configured to run as a service. This helps you with the idea of self-healing infrastructure. We said that Chef client can be configured to run as a cron job. It can be configured to run daemonized. And what this in the Chef client cookbook, as we saw, helps you configure that. The thing that's important about this means that if the configuration of a node under management has changed, Chef client will put it back to rights. Let's break some stuff. So if we were to go back, for example, we're logged into good old Chef Azure Baked 1, and I'm going to be a typey sysadmin, and then I might want to change. So I'm going to go ahead and I'm going to take a look at. So I'm like, oh, I've got these sites on here. It's this MyFace thing. I better check out the configuration of that. And I say, oh, you know what? If I recall correctly, I think I'm supposed to put, I think it's called MyFace. Let me go ahead and fix that real quick.
I'm just glad you didn't make it an E, Matt.
And then I'll go ahead and restart Apache, because that's what happens. And so this was on Azure Baked 1. Oh, it's not working. So Jeff,
hell?
I'm sorry. I don't think we're going to make our millions now.
What?
I mean, if someone could easily go in and just mess up our web servers, how are we going to possibly have the most powerful social network?
Yeah, how are we ever? What can we do? I mean, you know how long it's going to take someone to figure this out, Matt?
For someone to figure out the ridiculous thing that I just did. If only there was some way that we could do this in one command. In fact, actually, we probably don't even have to do it in one command.
In one command, right?
In one command.
It puts everything back to where it should be.
Now, of course, as we recall, this node is set to have Chef client run every 30 minutes. So even if, so you're seeing what looks like human intervention. That's simply because we didn't think anybody on the webinar wanted to sit around and wait for half an hour for the next time for the Chef client to run. So we're doing it by hand. Okay. And we can see the Chef client is running away, and it should have put everything back to rights. Let's take a look. And we have MyFace back. So I am breathing a sigh of relief that we shall now have received our billions.
Yeah, they're on their way.
So thanks so much, Jeff and Matt. First question we have here is, can Chef also remove software like Apache and MySQL?
So absolutely, because just like we said, you're defining the state that you want it to be in. So when we say we want, so the thing that's important is we're not telling Chef install MySQL. We're telling Chef ensure that MySQL is installed. Now, likewise, we can tell Chef ensure that MySQL is not installed. Now, that being said, we have to explicitly state that, just because because otherwise Chef would only have packages on there you told it about. So, but similarly, that I might say, you know, package Apache 2 action install, I would say action remove, and that would ensure if it was there, it no longer remain there after the Chef run.
And then another question we got here is, can Knife Azure delete a VM?
Yes. Knife Azure can actually delete a VM. Not only can it delete and remove the VM from Azure, but there is also a flag that you can put in that will remove it from the Chef infrastructure as well. So it can purge it from both systems completely. Good question. Very good question.
Awesome. Well, that's all the questions we got from our audience here today. But if you get home, you're trying this out, and you come up with some more questions for Jeff and Matt, Their contact information is on the screen right now. Both their email and their Twitter handles. Matt and Jeff love Twitter, so feel free to reach out to them there, or if it's a longer question, email is great as well.
And Matt doesn't sleep either, so.
Apparently not. No.
Yeah, 24/7.
Yeah.
I've also got 10th Magnitude and Chef's Twitter handles up on the screen right now. Feel free to follow both 10th Magnitude and Chef to stay up to date on more Chef Azure awesomeness. We're going to be having a few more of these webinars. We'll also keep you up to date with any other events that we think will be interesting. You'll also see on the screen the source code for this webinar is all up there as well. And again, we have that introduction email, or sorry, that introduction link. So if you want to review, get a full introduction to Chef and Azure, I encourage you to go ahead and check out our original episode in this webinar.